Good morning. We are going to look at churn rates in the telecom data set and look at our classification models that we can make to help predict churn. Basically, we're trying to build the best classification model to predict churn rate. That is, which customers are going to leave their service. And we're going to do that by examining the data set we have of information about our customers, looking at the predictors that we can use to help us predict churn rate, build a baseline model to work through and use visualizations to help us see which models work best to predict churn rate. And one of the things we can start with is some of our predictors, looking at them visually. And one of the predictors that I wanted to highlight here was customer service calls. And if you look at first the bar graph on the left here, customers with 4 or more calls did have a much higher rate of churn. You can contrast that with the box plot on the right. Looking at customers who did churn, how many customer service calls they made. So they're very similar, just kind of different ways to look at the fact that customer service calls definitely had a great effect on churn. We're going to be seeing a lot more of that as we move through the modeling here. Another factor I wanted to look at just for interest was churn rate by state. You can see some states are have higher rates than others. There certainly could be looked into there. These are just kind of a few of the predictors that we can be looking at when we make our modeling. As we begin our modeling, we can work through several iterations of it, but I wanted to start with one satisfactory model that we can just kind of use as a baseline and start from there. And we're going to be focusing on recall, which more specifically is false negatives. In other words, minimizing the rate at which our predictors think somebody will not churn when they end up churning. We want to minimize that false negative in our prediction modeling. Excuse me. The alternative, someone who our model thinks will churn but won't, is not great either. However, the consequences of that for this specific business problem are less. We're going to be building 2 models we think are very high quality, and we're going to kind of tweak those together and see where we can get. Our first, the random forest classifier, had a very good consistency between our training and our testing data. And you can see the feature importances based on this model here on the right. And as expected, customer service calls is right at the top of the list. International plan, day charges, and day minutes. Again, very high in relation to churn rate, which is something that we really want to be keeping in mind. Building a confusion matrix, as seen here for every model, really can help us visualize what we're looking at. If you look at this lower left corner, you can see the false negatives. What our model predicted as a 0, not churn, is actually a 1, a churn. This is the number we're looking to minimize throughout all our models. This one worked better than many of the others that we had used. Our gradient boosting classifier, the second model we ended up using, a better trained model. The test set performed comparably to the random forest model. Better false positives here, not what we were going for, but we'll take it. The prediction accuracy of this was higher. These 2 kind of can both work very well. Each have their own parameters that any future modeling can tune, and would be a definite good idea to do as we work through this. And then we can use Lime, which is what allows us to make these interesting visualizations here. We can look at the factors that relate to churn more numerically. And if you look at customer service calls, lack of a voicemail plan, this particular example, the model is very 100% confident, actually, that this customer will churn. And customer service calls, this person had 4 calls. And based on that, the model is confident that the customer will churn. So these visualizations per customer can be great to look at in your decisions. Some of the things that this modeling could lead to: reducing customer service calls. Seems like that needs to be a priority here. International plans, definitely for anybody that makes international calls, an international plan should be made or discussed with the customer. And then day minutes, day rates, since that had such a correlation, the adjustment rates could be needed for those accounts. And that can all kind of be tuned with any future iterations of the models, either the gradient booster or the random forest can be tuned to kind of better reflect what we need to do as a business. Thank you very much.